today's class. I think people will join. Here, I already, this is our LMS page. I just want to show you 11 lectures which I recorded. I think I took around 15 lectures, but I recorded only 11. I forgot the remaining lectures. So 11 lectures I put here. So is there any problem in accessing it? No, right? You can access the video lectures, right?
Yes, sir.
Okay. Then in unit 2, I already took some two periods. I think this is the third period. Second period, second lecture, I didn't load because I have to download from that site. Today I'll do. So today's and last class, that is on Fridays, I'll put here, right? So the notes already I'm putting the entire notes, lecture notes, class notes also I put the entire class notes, lecture, whatever I am showing you. And ebooks are also given, two ebooks what I am showing you. University question papers are also there. So I think you make use of these facilities. And tutorial 1 is over, which will be for 10 marks. That whoever is submitted, I have to grade them. I didn't do it. Even CAT I didn't grade. I just downloaded. I'm seeing it. I think this week I need to give the marks for both tutorials and this. The other one, second tutorial. So I will be conducting 3 tutorials, 1, 2, and 3. If time permits, 4 and 5 also. So each tutorial will be 10 marks. And at the end, I have to give for a 10 marks assignment. For that, I'll add all that and divide by how many I'll take an average, right? So each one will be 10 marks. So second one also I opened. It's around again 15 questions in unit 2 problems. This will be available till 31st August, right? So start doing the problems already. Two that is CSTR design expression is over, so you can do that problems, right? So till 31st, I'm giving you time because again the second cat also will start. So I have to see to that I have to give one more, right? So 31st till night time I gave. So hope you do it and then try. Today we'll finish off PFR. So once you know these two, I think you can do most of the problems. Okay. I'll do some problems. Don't bother. Maybe this week I'll be doing, maybe on Thursday I'll be doing some problems, or if time permits, Wednesday itself I'll do. Some problems I'll do, but most of the problems you have to do here because syllabus is vast. I cannot go on staying here. One more thing what I'm doing is because I'm giving only 3 periods. I'm putting Saturday as a 4th period. So every Saturday, 8:30 to 9:30, I'm just doing it. If you are free, you call me. Otherwise, you can read your own the material, whatever I put, right? Because as the HOD told, Saturday I have to take because it's a regular period. Because only 3 periods they gave. So if you are willing, I can take. If I'm free, right? So I told you to tell, but none of you people told. Even Guru didn't tell me anything about this. But I have to give because otherwise I won't get the period. So I'm just adding every week one period. So that is for your information. So I have to give the attendance also. Last 5 weeks, I have to give the till 14th. I have to give the attendance. Already, you can see your attendance in your LMS page. So based on that, I think 20 periods I took it. So you know how many periods you came and how many periods you didn't come. So based on that, I'll be giving the marks, and marks I'll show you maybe in 2 days time before I upload into the COE page. That's all from my side to give this what do you call this instructions. Let us go to the regular thing. Again, I repeat to you, some I received only here in CAT 1 tutorial. You can see how many I received. 59 only I received. So 6 people didn't give it, so they lose the mark. So don't later ask me why I got less marks in what you call assignments. Right? I gave enough time for you. I changed enough time this, but you people are not bothered. So 6 people, you lose the marks. But the cat one, I received all the cat one in the time, all 65. So I'll put a code. And even the assignments, I saw some assignments, tutorials. Some people didn't do, lot of people didn't do 15 questions. If you are not doing 15 questions, you lose the marks. Some of you done only 7. I don't know, maybe it's a mistake of you uploading or something like that. But a lot of people submitted only with 7, 8, like that. Few people, most of the people gave 15, but a lot of some people didn't do all the 15, right? If you do all the 15 only, you get 10 out of 10, right? So that I make you should, because this time the people are telling the marks, everything, we cannot allot more than 95 or something like that. So there should be a lot of variations. That's what people are telling, even the COE, because otherwise Anna University people are creating problems. So they are telling everything to do as per the regular thing. So we cannot boost your marks unless you're not giving, right? That's one thing I like to make myself clear, because it is difficult for me also to track all the submissions and all. But here, not only my subject, every subject, I don't think you can get more than 95. Earlier, we used to putting 99 like that also. But they are telling only some 5 to 6 students can only get 90 to 95. Like that, they're giving some variations. So I don't know how we can do it, but that's how it is going to be done in all the subjects. We cannot, they are telling to put the marks from 60, no, rather than going from 90s or something like that. Okay. So that is from our end. I don't think it is your botheration. It's our botheration. But I just want to keep you informed. That is why I'm conducting the tutorials here itself, so that I'll have a track of who submitted and who didn't submit. Even some people who gave assignment or a test paper by the mail, I just asking you them to again send it through this, because I will have a record. If you are sending it to me by mail, I receive more than some 20 to 25 mails per day. So in that process, I lose who submitted, who didn't submit, right? So try to stick to this particular time, and then if any difficulty is there, you just before itself tell, so that I'll take that corrective actions. Okay. So with that, I'll just start. Already tutorial 2 is available here. Please, all of you, I'm giving, this was kept more than some 4 to 5 days back. I don't know how many of you saw this, but I just like to show you all the people. Till 31st, I will accept night. So some problems, yeah, I'm giving you the ebook also. You can see in that and then start writing. Okay. So meanwhile, I'll be teaching you today the CSTR plug flow reactor. We'll go back to this presentation, and then
Sir,
yeah, yes, ma'am.
sir, the video lectures are not playing, sir. Like you're not able to view the video.
Is it for all the people or only for some people? Because I'm receiving some mails that someone is requesting my thing, but I made it everything open. Is
Sir,
all the people?
yesterday I checked for Unit 2 lectures, sir.
It's not.
Yes, sir. It wasn't playing, sir.
Just ask with someone else, because I am keeping
Sir,
everything open, no restricted, nothing. Yeah.
We are not able to access in LMS, sir.
For what? This
For
videos?
the lectures videos, yes, sir.
Only some people or all the people it is like that? Just I like to know the view of all the, because here if I show you in my thing, I can access. So it is from my side, but I need to, yeah, you can see my videos right here now. Yeah. So I don't know what is happening with your end. I'll just try. Is it for all the people like that? Just give me some feedback, so that I'll, if at all, I can change from side. From my side, I'll just do it. Okay. Is it all the people like that, Guru? Yamini, you can check and then send to me what video lectures are being not opened. Okay, Guru, you are there?
Sure, sir. I'll check. I'll check and.
Yeah, I think a lot of disturbance with you. I think you please try to find out what people or what video are able to see, and then I'll see maybe some restrictions, because generally I'm giving every option to open, but maybe without my knowledge something is happening. If it is not going to get open, I will just reload with some other credentials. Okay. Yeah, we'll go back to the class. Let us God bless. Any other ma? Any other you want to talk to me or something like that? Shall we go to the class? Yeah, you can feel open, because you tell, then only I know, right? I don't know that some of you are not able to open it. Yeah, because I too get some mails that this person is requesting my help and all, but I don't know why it is being coming like that. Huh? From my end, I think I did everything pakka, but I'll recheck again. Okay. So let us go to the previous thing. We are discussing about this, what do you call, this reactor, steady state reactor, where we got the final expression. This is a uniform reactor, right? Where the contents are uniform, whatever is going out, you are keeping an assumption that whatever is this concentration, it is coming out with the same concentration. And I'm using the material balance. I put one over the other, and finally got one expression to is this. I think I missed this. I'll just write it here. So this is tau V by Fa naught, V by Fa naught is equal to, sorry, something is disturbing here. I'll just again redo that. So V by Fa naught, V by I don't know why it is coming. V by Fa naught is tau by Ca naught is Xa by minus R. This is a very important expression. You can compare these two or whatever way you want, and then do, and then this will be the graphs, right? Corresponding graphs for Xa or the concentration. So the area of the rectangle will give you the volume required or the tau. The tau is nothing but the space time, right? So like that, we went for first order and second order reactions. So in here, we get one important number, dimensionless number is Damn-Kohler number, which tells Damn-Kohler number is tau k. That is, tau is the space time, k is the reaction rate constant. So for a first order process, tau is seconds and k is per second. So tau k will be dimensionless. So how this dimensionless, what do you call, Damn-Kohler number is very important, because if you want high conversion, your high value of Damn-Kohler number should be there. So if the Damn-Kohler number value is less, obviously you get a low conversion, because it directly depends on the tau. Tau, it's space time, that is nothing but how much time it is spending inside the reactor. More the time spent inside the reactor, more will be the conversion. Yeah, we saw for a volume change. Volume change, this expression is very important, because this sigma A will come into picture. You can calculate k tau, because extra term is coming. If this is going to be no expansion, then this term will be 0. Only you are left with Xa by 1 minus Xa. But if there is an expansion factor, this big term will come into picture, right? So this all we saw earlier. Now today we have to see one more important thing is plug flow reactor. That is otherwise called as PFR or it is called as a tubular flow reactor. Otherwise, some people it can call as any other type of reactor, right? So plug flow reactor is nothing but the reactions are happening in a tube. Is a same tube that is diameter, where the one end input is going, the other end output is coming out. So input, let it be Ca naught, that is the initial concentration. Fa naught is the flow rate, molar flow rate initially. Xa naught is the initial conversion. I am writing for only A, that is one reactant. V naught is nothing but the volumetric flow rate here. CAF is the final flow rate of concentration. FAF is the final molar flow rate. XAF is the final conversion, and VF is the final volumetric flow rate. As some people they put F, or some people just they like that V itself it is enough. So to show it is final, they are putting F subscript, right? So here what will happen, because the concentration is changing in this particular axis, here there will be one concentration, here will be one more concentration, because the reaction is happening along the length of the tube, right? So along the length, the concentration is changing. How the concentration is changing? It's not a linear. Therefore, you get a parabolic curve profile, right? So this is the XA versus the distance through the reactor. This is 0 distance and this is the L distance. So initially at 0, the conversion is 0. The conversion will go on increasing and then goes to a maximum at the end of the reactor. Because why the conversion will be maximum? The more time it is spending inside the reactor, more will be the concentration conversion, right? So since it is going not a linear, you get a curve. If it is a linear, you get a straight line like this. You get a straight line where the slope will be same. But since it is non-linear, you get a curve. Each part of the curve you will have different slope. So when you are getting a non-linear thing, that is the concentration. If I know the concentration here, I cannot predict the concentration here. That is what is non-linear. Linear in the sense, whatever concentration is here, I can predict anywhere concentration, because it is just like a straight line. I just put M slope is same, then I can do. But this is a non-linear, I cannot predict. Therefore, you get a curve. So what you have to do is, you have to take some small elemental strip, just like a thin slice. The thin slice, let it be having what do you call? The distance is delta X or delta T here. And through that, here is the input and here is the output. So the change in the conversion, let it be dxa during this particular path, right? In this path, there will be conversion change, because there will be one conversion here, there will be one more conversion here. So the difference between the conversion, let it be dxa. That is what is the y. The difference in the x is nothing but the thickness of this small elemental strip. So that let you assume the volume of this particular disk. You know the radius into this particular radius into this particular circumference will give you the volume. So let the volume of this small elemental strip is dB. So in this strip, let Fa is the flow rate which is going in. So here is Fa naught. Fa naught is the initial flow rate, but Fa is the flow rate through which it is entering into the strip. Now, if it is Fa is the flow rate entering in the strip, it is coming out because it is having some length to travel. During that length, let the conversion changes. That is nothing but dFA. That is the rate at which the conversion is changing in that small elemental strip. So Fa is the molar flow rate initially. Fa plus dFA is the outlet molar flow rate from this elemental disk. So using this, will substitute in the design expression, or you do a mass balance, then what will happen? You get a differential equation. Then you integrate between the limits of L is 0 and L is L, or whatever length you want, right? This is the general case. Anywhere you will do, even in fluid mechanics, mass transfer, anywhere, if there is a non-linearity inside, even heat exchangers, if there is a non-linearity inside, you take a small elemental strip, do any mass balance or force balance. Force balance is for what do you call what is that, fluid mechanics, and momentum balance for momentum transfer, mass balance, energy balance, force balance, whatever balance you do, you get a differential equation that you have to solve between the limits, because you have this elemental step. Then you are you know how the behavior is. Then you should know what, at the two extremes, how the behavior, and then you tell that these are the two extremes by which it is going to your performance will change from this end to that end, like that, right? So this is the engineering way of design, right? Any in chemical engineering, we do a design like this. Take a small elemental strip and do whatever balance you want. Here we do mass balance, right? So in that, for any component A, the material balance or on the mole basis over a differential element dV. So this is the differential element dV. Again, input, output, disappearance, and accumulation. Again, here it is rate is there, because with the time it changes. So rate of input is rate of output as a rate of disappearance plus rate of accumulation. At a steady state, you are not having AQD accumulation. That is how much is going in, that much is coming out. Initially, there will be accumulation, but putting here, FA is nothing but moles per second. What is the output? FA plus DFA. That is the elemental strip. It is changing. Therefore, FA plus DFA. And how much is the disappearance? Disappearance is nothing but minus RA is the disappearance into delta V, because 1 by V we get, right? So volume of the fluid and volume of the fluid get cancelled out. So you are left with moles of A per time. That is what you have to use. In all the three cases, in all the three expressions, the unit should be same. Disappearance, generally you'll write minus RA into V. V is the volume of the reactor, but you are putting here dV because you are considering only this elemental volume, which is having a volume of dV, right? So you are not considering the entire volume. You will consider the entire volume when you differentiate, right? Or integrate, right? So dV, RA is nothing but moles per moles A reacting by unit time into volume of the fluid and into volume of the fluid. So volume gets cancelled out. So you get moles of time. So let us substitute everything in this. FA is FA plus DFA plus minus RA into dV. So if you do this, these two gets cancelled out. So minus DFA, you get this at this side. Minus DFA is minus RA into dV. Sorry, D is there here. D is there. It's a mistake, right? D is there. So here I am writing dV, but here B is missing. Please make a note of it, right? So minus D, FA is nothing but FA naught into 1 minus XA, we can write, is minus RA into dV. So if you differentiate this, if you FA naught into 1 is FA naught minus FA naught XA. So differential of FA naught is 0. So differential of FA naught minus DXA is minus FA naught DXA. Here 1 minus, here 1 minus, positive you get. FA naught into DXA is minus RA into dV. Any doubt here? I'll just put this, discard this. I'll just change it. Otherwise, I may forget. Yeah, it's not that easy to do all this. Really becomes very difficult to I think I changed it now. Yeah. Now I think it is fine. I need to, otherwise I may forget what is the mistake. Okay. Any doubt here? Any doubt in this slides, ma? No doubt.
No, sir.
Shall I go for the next slide? So you are left with
Yes,
F naught dxa is minus Ra into dV. I am just writing the same thing here. If you rearrange this equation, you get all the dV terms to one side and xa terms to another side. So dV by F naught, dV, you get this here and this here down. So dV by F naught is dxa by minus Ra. So you get like this. dV by F naught is dxa by minus Ra. I think extra line is coming. So you integrate between the limits. That is what I just showed you there. Just once again, let me discard all this. Yeah. So you go from 0 to V because you are getting for that elemental strip how is the change, but the volume changes from 0 to V. When the volume is changing from 0 to V, your conversion changes from 0 to XAF. So dV F naught is constant, initial molar flow rate, it is going to be constant. You can take outside the integral. Integral of dV goes from 0 to V is V. So if this integration, if you substitute the limits, we get V by F naught is integral 0 to XAF dxa by minus Ra. Correct? So we can write a V as F naught into this particular thing. Because F naught, I get this. We know, but we already know that V by F naught is nothing but tau by C naught. So the final expression which you get here is this. Yeah, here. V by F naught is tau by C naught integral 0 to XA or XAF dxa by minus Ra. Now, can anyone tell what is the difference between this design expression and the design expression of mixed flow reactor? In mixed flow reactor, you get a design expression like this. V by F naught is tau by Ca naught is Xa by minus Ra. This is for MFR and this is for PFR. Yeah, what is the difference? Can you notice what is the difference? First term is same. Second term is also same. What is happening to the third term? What is happening to the third term? This I'm just putting. Sorry, I'm just putting this. Yeah, MFR. Yeah. What is happening to the third term? In third term, for a MFR, you are not getting the integral. Whereas for a PFR, you get an integral. So you know integral is very difficult to do there. Why we get an integral? Because the concentration is changing during the length of the time or length of the time and length of the reactor. Whereas here you are assuming the concentration is uniform. That is why you won't get that integral. But here you get an integral, right? That is the difference. Either you can put in terms of XAs or you can put in terms of conversions also, rather concentrations also, by just resubstituting all the thing in terms of conversions. You can write tau as V by V naught, volume by volumetric flow rate. So volumetric flow rate is nothing but F naught by V naught, Ca naught. So if tau you can calculate as V Ca naught by F naught. This already we know that you can put here. Tau is nothing but V Ca naught by F naught. Then Ca naught cancels. You are left with V by F naught. That is equal to CA naught into this particular thing. You can change still if you are if you want, you can change to DXA to conversions concentrations also. When you are changing this DXA to concentration, your limit also changes to concentration, right? So you won't keep conversions, right? So again, you draw what do you call? If you want to calculate this volume of a reactor or tau of a reactor, again, minus 1 by RA versus XA, you draw a graph, right? Minus 1 by RA on the y-axis and x-axis. Since integral is there, your curve will go like this. The area under the curve will give you, the area under the curve will give you either it is V, that is the volume, or tau. That is what I'll show you here. So you can calculate this V by Fa naught, tau by Ca naught, minus 1 by RA versus XA. The curve will go like this. So if you want a conversion of whatever conversion, you put a line to that particular point, the area under the curve, because it is the integral, right? Earlier you put this particular thing, because the area of a rectangle you put for a CSTR, but here, since integral is there, your integral in the sense area under the curve, so you can calculate this particular area under the curve. That will give you V or tau. Either you can write for XAs or you can write for CA. So you know this is the CA naught, initial concentration. Whatever concentration you want, this will be the rate curve. This comes from your experiment. You draw it, and then whatever CA you want, you put a line. Again, there is an integral. So area under the curve will give you the integral. From that, you can calculate the time or tau or whatever it is, volume. Because CA naught you know, Fa naught you know, this value if you know, you can calculate the volume of the reactor required, right? So remember, for a CSTR, it is the area of a rectangle. That it will be easy because you know this length and this length, then you can multiply both to give you the area of a rectangle. But here there is an integral for a PFR. Therefore, to calculate the area under the curve, you have to count the number of rectangle or squares. That is one way. And you have to generalize this half squares as one, two half squares as one half square. The other one, what you do to calculate this particular thing, there are a number of methods. One method, simple method is, this particular thing is the change. So try to calculate what is the difference in between this and this. What is the difference? So take a midpoint, and then draw a line through the midpoint, join this particular thing, then calculate the area of this rectangle, that it will be the area of this rectangle, area under the curve, because here something is added, which you need to do this. So here some assumption is how much is top is nothing but this. So this way also you can do. That is, this is called as an averaging technique. So you find whatever is the change, you find a midpoint to that and draw a line, and then make a rectangle out of it, and then find the area under the curve, area of the rectangle. That is nothing but the area under the curve that you generalize. Till third method also is there. You can see in the book also, which is a bit complicated. You have to find the slopes and then find, right? So out of all the three methods, I think this method will be easy. Otherwise, you have to count the number of squares and then make generalization of how much is the square. That many square into the area of each square will give you the volume under this particular curve. Any doubt by here? Any doubt? Any doubt here? So find out the center of this two, and then draw a line, and then area of a rectangle is easy to calculate rather than the area under the curve. Yeah, this is the difference between that plug flow reactor and a mixed flow reactor. Now, if you want to compare both, now where the volume of the reactor is high, can anyone tell? Because if this is going to be a CSTR, then area of this entire thing, area of this entire thing is for CSTR, MFR. If you are assuming it is CSTR, if you are doing, then area under the curve only is the MFR, CSTR, PFR. So area under the curve you put is like this dotted line. So this particular thing is PFR. Now tell me where the volume will be more for a particular concentration or particular XA. If you are considering XA conversion, this entire thing will be the CSTR, and this dotted part is nothing but PFR. So from the figure, you tell me if you want to have volume, which one will have more volume, either MFR or PFR for a concentration, whatever may be the conversion. Let it be around 90% conversion. Yeah. Please tell. Yeah, just see the figure and then tell where the volume is more. Area of a rectangle is more or area on the curve is more? Area of a rectangle is MFR. Area under the curve is PFR. Which is more? No answer. Don't know.
MFR.
Yeah, someone is giving MFR. Yeah. Generally, for a particular conversion, area of MFR is much more. So for a 90% conversion, if you are assuming A is giving some R, and if you want 90% conversion, here you get some V, MFR, you get some V. If the same reaction is happening in a PFR, you can get this 90% conversion with a lesser volume than that of MFR, because you can see here. That is the biggest thing. So MFR requires more volume in the sense more tau or T. That is how much time it is spending inside the reactor. So volume of MFR is much more than PFR. So for a same conversion, if you are having an option to choose any of the reactor, PFR or MFR, definitely you choose PFR because it gives lesser volume. So lesser volume in the sense lesser will be the material required. Lesser is the material required, lesser will be the operation cost, and you get more profit. It is just like now you are going now you want to go from Trichy, from here to Trichy. There is road facility available, there is a rail facility available, there is air facility available. Air facility is costly, so some people will go. A common man, either he can go in a bus or train. Both tickets are available. Let us assume that both tickets are available. So let bus is taking some 200 rupees from here to Trichy. Maybe I don't know what is the amount. I'm just taking some example. Let you go by train, maybe third class or sleeper class. Let you are having some 185 rupees for a train ticket and 200 rupees for bus ticket. So both tickets are available. What do you prefer? Generally, we prefer train because it is less cost there in the example. Sometimes train may be costly also, right? So in my example, I'm putting 185 rupees for train and 200 rupees for bus. Therefore, definitely I'll go for a train since both tickets are available. It's the same thing here. both reactors are available and you want the same conversion, generally we go for MFR, sorry, PFR, because it requires less volume. Correct. Any doubt here? Now I want to put one more question now. What will be the question? Can you guess? What will be my next question? The question what I asked earlier is, for the same conversion, one reactor is having more volume, another reactor is having less volume. So generally you go for the reactor which requires lesser volume. So obviously you go for PFR rather than MFR. Again, there will be a lot of advantages in using PFR. There will be a lot of disadvantages in using MFR. And again, the same is true for even PFR and MFR, right? Now my question comes. What is the question is, why the volume required for, okay, from the graph I can tell that the volume required for MFR is much greater than the volume required for PFR. This is from graphical point of view I am showing. But why there is a change in the volume required? Can anyone answer that question? It's a beautiful question. Yeah. Any idea why the volume or time required for a particular conversion or particular concentration in PFR will be much lesser compared to that of PFR, MFR? Or you can put the other way around. Why the volume required for MFR is much more than PFR for a same conversion or concentration, to achieve the same conversion or concentration? Yeah, anyone you can give the answer. It's an important question. Your next one unit is based on this particular topic only. Yeah, anyone wants to give anything? No one wants to get tell? Some make some wild guess. Very good, because lot of discussion should happen here. Yeah. If you are not answering the question, then I'll skip all that. Then you won't understand. Yeah. I require some answers so that I know what is your what do you call knowledge level, so that I will go from there. Yeah.
There is accumulation in MFR.
Accumulation in MFR, but we will be just having accumulation is 0 for both the things, right? Here PFR I am putting here also there will be accumulation like that, because once it is going in, that is coming out. Some things will be here, right? In this always, just like in PFR also you will have something. Yeah. Something is coming in, something is going out. Always some accumulation will be here. Here also you are putting accumulation 0. Yeah, I think I answered that question earlier. Who answered that call? Yeah, I think did it make sense what I gave? Yeah, that is not that. Yeah, something else. Yeah, I think something else. Yeah, another. Yeah, go ahead.
The reactant is moving in PFR, but it is stationary in CSTR for a particular time.
Yeah, very good. But it's not stationary. It is moving right here also, because continuous input is there, continuous output is there. So there is a chance that the reactant is coming inside, immediately it may go out also. It's not that outlet is here, outlet can be here also. Lot of the times outlet will be at the top only, not at the down. This it may be wrong. So as you tell, it may go out. Yeah. In that process, what is happening? What is happening? Yeah.
Sir,
Make
time spent in the reactor
X is
is more
0.
case of PFR.
Time spent by the.
The time spent in the reactor is more in case of PFR, sir. So,
Mm, How-
whereas it is
how
comparative.
can you tell that PFR is having more time than MFR? Yeah.
Because when one component enters in, sir, only if exits, the next compound can enter, as you said.
Yeah. Here, as I tell, each component should pass through this reactor. So as you tell, one component, some fixed amount of time it has to spend. Okay. That's what you are
Yes, sir.
claiming, right? Good, good, good.
Yes, sir.
So here, what is happening? The same girl, I think. I don't know.
Sir,
Yeah.
sir,
What's your
whereas
name?
in MFR,
What's your name?
sir, Varsha.
Varsha. Okay. Because I cannot see you because I am projecting it, so I don't know who is talking. Yeah. Tell your name and then talk so that I'll have some idea. Yeah. Here, what is happening? Yeah, Varsha. What is happening?
Sir, whereas in MFR, I think there is continuous input and continuous output. So I'm just guessing the retention time will be less.
Yeah. Yeah. Guess is correct. Guess is correct. But why the retention time is less? Correct. What you told is absolutely correct. But in your sense, it is absolutely
Maybe
correct.
it is because the concentration is uniform throughout.
Yeah, concentration is uniform throughout. Why this fellow will stay more time here? Concentration is uniform, correct. But for that, why this fellow stays more time here than this fellow, or less time here than this fellow? This fellow, you are telling some X time it is staying, and you are claiming that this fellow, in this fellow, you are having less time. That is what you are claiming, right, Varsha?
Yes, sir.
In that process, again, why this concentration is talking? You talk only this, right? Okay, good. Good try. The answer is correct, but you don't know how to express yourself. But if I tell, the answer will be similar to what you tell, what you told already, but in a different view.
Yes.
Okay, good, 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 good try. Yeah, anyone else want to talk? It's a beautiful thing, right? It's a very good point. I like to add one more point here, right? I'll just come to this particular slide. Yes, this slide, right? This is here I like to ask two questions. One question is why the volume of MFR is much greater than the PFR. That already I asked, right? So I got some answer. One more answer is, now can anyone tell what is the design expression for batch reactor? For a batch reactor, what is the design expression? T by Ca naught is integral 0 to Xa dxa by minus Ra, correct? This is the batch reactor, right? What is the difference between that and this? What is the difference between that expression and this expression? T is tau, that's the time, by Ca naught is integral 0 to Xa or Xaf dxa by minus Ra. Only V by Fa naught is extra, but I can compare these two, right? Now my question, batch reactor is, what is batch? There is no continuous process. Accumulation is there. But in continuous process, PFR is a continuous process where there is no accumulation. There is continuous input, there is continuous output. Whereas in a batch reactor, there is no input, there is no output. That is at a steady state, I mean to tell, right? Initially, there will be input and you are making for some time to react, and then you are taking out. Even though one is batch process, another is continuous process, the design equation is same. Surprising, right? Anyone surprised because of that? Maybe you didn't notice. Since I wrote here, T by C naught is integral 0 to XA dxa by minus RA. Either you can write in terms of concentration or conversion or number of moles also. dNA by minus RA also you can write. Based on that, it is integral values will change, right? My question, second question is here this. Why this PFR and batch reactor is having the same performance equation? A surprising result. Two questions are, one is if you compare MFR and PFR, why the volume required for MFR is much more than PFR? The second question is, for the same conversion or for the same conversion XA, your PFR and the batch reactor expression is same. For the same conversion, the time required is same. How come you justify this? Is it only because of this expression we have to tell that batch reactor is equal to the plug flow?
Sir,
Or some theory is behind it? Yeah, go ahead, man. Name your. Yeah. Yeah, someone told here, sir. Yeah.
sir, hello.
Ah, go ahead.
Sir,
what's your name?
we have a
What's your name? Please tell your name.
Rohit, sir.
Rohit. Go ahead, Rohit. What is your view? Surprising
If
result,
we
right?
have,
Huh? Did you surprise with the result? Just tell your view. Did you surprise? Both are having the same design
Yes, sir.
expressions. Yeah. Tell me why it is your view. Good.
we have a PFR of some high length that is nearly infinite length. It acts as a batch reactor.
Why it is like that? Answer is absolutely correct. But why? Why? How can you tell that? Answer is correct. I just want your view because I am thinking something. Whether you are in the thinking the same thing or just like that you are telling. I just want to know. Yeah. Did you search in net?
No, sir, because
No. Yeah. Tell me. Why?
if it is of high length means the accumulation will not be zero, so we can consider there is some accumulation as batch reactor.
Accumulation is not zero in the sense at a steady state only you make that assumption, right? So initially
Yes.
there will be the molecule. You can see here. Initially from this molecule is going from this end till this particular end. You are assuming it is unsteady state. Once the material starts to come out, that is where you are doing the material balance. So that time accumulation will be zero, right? How much is going in, that much is coming out. Now, what is your point in this? You are telling some accumulation is there inside. Accumulation is zero, right? That is what we put here. Rate of accumulation is zero here.
But if we consider for a particular time, we will have some accumulation. If we only consider the input point and the output point,
Even then what is the difference between batch reactor and MFR? Both looks the same, right? So this is the reactor, and this is the volume, and this is the stirrer, this is the inlet, and this is the outlet. Both batch process and in a batch process, this is not there, this is not there. In a continuous MFR, this is there, this is there. The reaction is happening in the same thing, right? So then your batch reactor and MFR also should be same, right? No, does it my point make sense?
I had this kind of thinking and told.
Yeah, good. Very good try. Yeah. Any other answer you want to give? Yeah, this very good point here. That is why I'm waiting long time, because your entire CRE is based on this concept only. That is why I'm just holding the answer to give. Yeah. I don't want to give the answer immediately, because the moment I give the answer, the rest of the thing you won't have that curiosity. Bahubali 2 was hit because why Katappa killed Bahubali. If he could have revealed in the first part itself, then there is no curiosity. Then you won't learn anything. Ian, I just want to keep that point alive for some more time, so that you will have the curiosity to know why this design expressions, even though there is different design expressions, or this volume is less, or if the same for the same design expressions, why it is coming same for PFR and batch reactor. I don't want to give the answer now. In the next class, maybe in the next class, I'll talk about it, because it's already 11:55. Still a lot of time discussion I have to make on that, because I can just leave that point there, giving the answer, but you won't appreciate it. I just want to make you clear for everyone why it is like that. So any question can come from on that, you have to definitely give answer, even or entire class, right? So I'll keep that option open. I don't want to reveal the answer. The moment I reveal, I know what will happen. The curiosity will die down, because the answer looks very simple. But giving answer and giving with your reasonable justification is what is more required. So try to think, try to Google it and find out the answer, and you send me in WhatsApp chat or something like that. What is your view on it? Or you can mail also. I'll just go through all that and then see how far you are correct. And not only giving the answer, you have to give the justification also. Even a small kid should understand why that particular thing is correct. That justification, right? It's not that only engineering student will understand your justification. Even a layman should understand what is the justification. Okay. Guru? Yamini?
Sir,
Yeah. I just want to
yes,
keep that
attendance is not
option
sir.
open, and I like to continue the class in the next class. So try to have some healthy discussion among with you and come out with some good answers, right? This point is very good. That I'll keep it there, right? So with that, I today's class I end. I know you will have a lot of doubts. The same question will be start ringing in your mind. Just I like to keep that same question for some more time with you before I reveal the answer. That answer will be revealed in the next class. Thank you for joining. I stop the recording now. Yeah, any doubts?